Okay, well, welcome. We're going to be talking today about the curse of the testing pyramid. We're going to sprinkle in some curses of Egyptian tombs that were discovered in there, and it is going to tie together. In the Valley of the Tombs in Egypt, there's obviously a bunch of Valley of the Pharaohs in Egypt. There's a bunch of tombs. And some of these were discovered in not so long ago. And here's an article from New York Times. I think this is in 1922. So when they first found the tomb of Tutankhamun, and the story that happened during that is they got into the tomb. I'll talk a little bit more about how it was discovered, but the main archaeologist that was driving things, had brought along a pet canary that he kept at where he was staying to keep him company, because it's evidently lonely out there. After they went in and broke into, or opened the seal on the tomb and got in, they got back that evening, they heard this noise, and a serpent had gotten in and had grabbed the canary in its mouth. And they got it away before he ate it, but it scared the canary to death and it died. And this was considered a very, very bad omen because the snake or the serpent that went ahead and got the canary was the same one that was supposed to be protecting the tomb. So these were the types of things that were going on when the Tutankhamun tomb was discovered. So here's a picture of, this is Carter over here. He's the archaeologist that had the canary. And then this is Lord, I'm going to say his name right, Carnarvon, right here. We'll talk more about him here in a little bit. And then the woman next to him is his daughter. Carnarvon he walks with a limp. He had been in a car accident, never fully recovered from it, lived in England, and at some point was told they needed to get out of England for his health occasionally. So he started going to Egypt and started collecting Egyptian artifacts and financing Carter's exploration of things. So this is at the top of the entrance of the tomb of Tutankhamun. I think this is before they actually got down into it. And I want to point out something here, that these three actually came back when no one was there and were the first ones to open up and go into the tomb. Once they found the opening, they sealed it off, and they were going to wait for the ministers of archaeology or whatever in Egypt. But then they came back that night and got into it and looked around a little bit. And I want to point out that every single one of these people here are now deceased. They have all died. And whether that's a coincidence or not, we'll talk about here in a minute. But this is Lord Carnarvon. This is his tomb where he was buried. He actually died in Egypt, I think within a year after when they opened it up. He had a mosquito bite and he cut it with a razor blade and somehow got blood poisoning and died there in Egypt. And they brought him back to his estate in England, and this is where he's buried. Now, one of the things that people discovered is after they actually got Tutankhamun's body out and started looking at it, they realized that he had a cut on his cheek. And they wondered if it might actually be in the same place that Lord Carnarvon had his cut on his cheek, but they didn't dig him up to find out, and they weren't sure exactly where the cut was. But that was something that was going around in the news and things. If this guy looks familiar in any ways, let me show you where he lived. This was his place. If you've watched Downton Abbey, this is the place that's featured on there. So it's Highclere Castle. His descendants still live there, and in the basement of this is a Egyptian artifact museum, and kind of telling the story of finding the tomb and stuff. And you can go visit that today. It's open. Downton Abbey has a lot to do with why people go and visit, and also why they've been able to do some repairs that were much needed that hadn't been done over the years. Now, Sir Arthur Conan Doyle attributed to Lord Carnarvon's death to elementals that were protecting the tomb. And there's other things that kind of happened around this time. At some point this is Sir Bruce Ingram. He went to see some of the tomb stuff, and Carter, who he said was just very, very nice, gave him a mummified hand as a paperweight. So I have a designer friend that I asked to draw a picture of it, because the hand had a curse written on it. And the curse was, "Cursed be he who moves my body, to him shall come fire, water, and pestilence." So Sir Bruce Ingram had this paperweight in his house, and something bad happened. His house caught on fire. So check, we got that one. Burned down a bunch of the house, and so they repaired it and stuff, and soon after that there was a flood. So then it was destroyed by water. At this point he thought maybe this wasn't all coincidence, so he got rid of the paperweight hand before he could be attacked by pestilence. Now around this time period, so this is around 1922, Mussolini had been given some mummies from somewhere in Egypt, and he kept them in his royal palace where he lived. After hearing about some of these things happening, he removed the mummies from his house because he thought it was just too dangerous to have them there. So here is a question for you. Based on what we've said so far, what do you think about the idea of there being a curse? And Carter died of, he died of cancer later on. There was another person involved that was smothered to death in their bed. Another person fell off 7 stories and died. So all these people involved in this died. Even the daughter, she's dead now. No, she died in 1980. But she is dead today. So we've got 18% of us think there definitely was a curse on the tomb. 5% says there probably was a curse, but people believed it, so they tended to die sooner. And then C, most of us are saying no curse. People just paid attention to bad things to reinforce the idea of a curse. And then 9% of us are, I'm not saying it's aliens, but it definitely was aliens. So we've got a wide range of opinions here. So that's good and healthy, right? So people that have gone through and studied it says statistically people associated with opening the tomb didn't die early. Now they did all die, but keep in mind it was in 1922. If anyone was a newborn baby there, they would be 101 years old today. So makes sense that a lot of them would have probably died out. So what was driving the idea of the curse? Well, it turns out these 3 had sold the rights to a newspaper to be there and write. It was the New York Times. So no other newspaper could report on this or be involved in it until later on. Now this caused a lot of ill will and stuff, but they also didn't want anybody sneaking up and actually getting into the tomb before they did. So they spread the idea that it was cursed, even though this particular tomb was one of the few that didn't actually have a curse on it. So to protect the tomb, they spread the stories about a curse. This is a picture of them at the top of it. So thing I want to bring up is that stories can influence behavior, and sometimes we forget to ask if they're actually true. So we can do lots of things that are influencing our behavior without asking whether is this actually true. And not only maybe it's been true in the past, maybe it's not today, but the idea of this curse was the story was spread and lots of people believed it because that was a story, and it's interesting to believe, and it makes a very, very nice story that all these people died that had gone down into the tomb and desecrated it. So let's talk about testing. Here's an example of how a lot of software projects go, or how a lot of work done. You've got some type of requirements, you figure out what you're going to do, and then you go through some development work, and then you do some manual testing, and then eventually gets deployed. So this part right here, for a lot of us, has probably experienced the pain of waiting for manual testing. This takes a long time. There's lots of stuff to test, and it can take a long time. So obviously, people started saying, let's find some tools to automate this. So we started having maybe manual testing, but also automated testing. And everyone lived happily ever after, right? That's it. There's the solution. Thank you for coming to my talk. I am finished. No, this isn't what actually happened for most of us. So let's see what describes your experience with recording UI interactions and then playing them back to test software. Does everybody live happily ever after? So A, people do that. B, it works great. C, useful as long as there are few enough to make it easy to maintain. D, kind of useful, but they break and take a long time to fix, or usually end up breaking and no one fixes them, so they get turned off. What has your experience been? Okay, we've got some people saying that it does work great, so that's cool. But it looks like most of us are kind of in this camp of it might be useful, but they break, take a long time to fix, or it takes so long that we end up just turning them off. There's some people that are finding this balance of saying we've got a few and they're useful but we've got to have a few enough that we can maintain them. And 8% of us are like, what? People are doing that? When did that start? Okay, so this is kind of our experience here. We've got maybe one or a few people that are saying it works great, but most of our experience has not been positive with this type of approach. So everyone lived happily ever after, except that they didn't. Before we were waiting on people to do the test, now we're waiting on people to update the tests. And sometimes that actually is worse and takes longer than the testing, depending on your situation. But the point is, this didn't solve all the pain. Can be very, very useful. But our problems are, they're slow to run. It's hard to tie a failed test back to the change. When you're just replacing your manual testing with automated testing, there's usually enough time between there that it's really hard to figure out what particular change caused a particular break, or was it just flakiness in the test? And the UI tests are very, very brittle, right? It's easy. You can make some small change that doesn't actually break it for the user, but breaks it for your test because your test can't find it, or there's timing issues. All kinds of things can go wrong in this. So what might be fast to run, easy to tie to a failed test back to a change, and not brittle, meaning you can refactor stuff. And so tests that are just working through the UI, if you go in and start changing the way the UI works, they're all going to break. In software code, there are refactoring tools when you're working directly with code and testing directly with code that you can say, I'm going to rename this method, but also anything that calls this method, rename that call. So I can rename this method here or change it in some way, but then change all 1,000 places that actually try to make this call. And with UI tests, that's not the case unless you use a particular approach, which we'll talk about in a minute. Okay, so meanwhile, people started doing test-driven development and found it was a great way to do development work. And test-driven development is fast to run. It's easy to tie back a failed test back to the change because you run them really often, right? You make a 5-line change and then run your test, and if it breaks and it worked before, you can be pretty confident that your 5-line change, something in there actually broke the way the test worked. And they're usually less brittle. They can be refactored. They usually have fewer dependencies. They're less likely to just be flaky because you're running stuff directly against the code instead of against the way that the user interacts with it. These don't test the user experience, though, typically, because they're testing the individual pieces of the code. Okay, so we've got these tests up here. They're fast to run, easy to tie to a failed test back to the change. They're not brittle, they can be refactored, etc. And then down here, we've got these UI tests that are slow to run, hard to tie a failed test back to the change, and the UI tests, so they're very, very brittle. So the thinking was, you may have people say, hey, let's do more of this up here, this stuff we like, and less of this stuff down here that we don't like. That's the thinking that led to the idea of a testing pyramid, where we've got a user interface test at the very top, so just a few of those. We've got integration tests that are kind of in the middle here, and maybe more of those, but not as many as the unit tests we have. They're testing all the individual pieces of things, and we'll have lots and lots of those types of tests. So user interface test things like this from the user standpoint. So we'll talk through these 3 things we just saw on the pyramid. User interface tests are going to test things from the user's point of view. So how does the user experience the software? Oftentimes they're created by the testing team after the fact to prove that they work. It usually is meant to replicate manual testing. So take what would happen manually and make that automated. And they're brittle and hard to refactor. And they're often slow to run because you've got to bring up the application, step through the application. So those are the things that you have with user interface tests. So from that standpoint, yeah, doing fewer of these seems like a good idea. Well, the integration test tests the way that things integrate. So it might be the way that your business logic interacts down with your database layer, or the way that these 2 modules work together. So the way that things all fit together. They often don't touch the UI at all because you're making calls directly against services or maybe even controllers. They don't always use the user's point of view because they're testing more of how the pieces fit together rather than how the user actually uses those pieces. They're usually easier to refactor, and they usually run moderately quickly. You may need to hit the database with it, but it's not something where you're actually taking everything through a browser, typically. Then our unit tests are small unit tests, often testing things at the method level. They never touch the user interface, and they don't always or don't usually integrate all the parts. So you're testing just a very small block of code. They also tend to run very, very quickly because one of the big differences between integration tests and unit tests is, in general, the unit test isn't going to need to stand up a lot of infrastructure to test it. So for example, if you were working with Spring or some framework like that, your integration test might actually stand up Spring and test the way everything hooks together. The unit test would probably just hit the individual methods to see how they work and prove that they work, and not even need the overhead of Spring. So, and these are just general, people put different things in different categories, but just generally talking about what makes up this testing pyramid. Okay, so, and this made a lot of sense in a lot of situations because, you know, tests that are really, really expensive and brittle and hard to change, let's do fewer of those, and then work our way down and then have lots and lots of unit tests down here. But then we got some new tools, right? We also found some new patterns. And there was this thing called the cloud that gave us some new capabilities. So question for you, which question seems most useful in deciding whether you should create a test or not? And now this may seem like a silly question. Okay, we've got one person that's like the Lego block shape is really where it's at. This may seem like a silly question, but it's easy for us to get caught up in a shape that was defined to solve problems that we may not have anymore, or maybe different problems today, or may have grown in different ways. So this brings us to our idea of the curse of the testing pyramid. So let's talk about some of the curses that we might run into if we're too focused on the shape of our tests, of how they distribute, and maybe not focused on the actual value they provide. So curse number one, trying to create a shape instead of value. We should be asking ourselves, what return on investment do I get from each test, instead of what shape is made if I were to represent my test with Lego blocks. So instead of asking ourselves, oh, you know what, look, I'm going to write another test, and I think I've got too many UI tests. I should write a unit test instead. Well, now I'm focused on the shape instead of what's the best way to get a return on investment for this next test I'm getting ready to work on. And as way of an analogy, so here's the distribution of IQs, right? Generally, they're centered around 100. And this gets recentered regularly because the IQs are actually shifting this way. The way that the tests are done is about 3 points per decade. Lots of potential reasons for that. But imagine that this wasn't shifting and we saw this start to skew to the right. And most of the shift comes from there being fewer people at the lower end of it. So the shape of this thing is moving a little bit to the right. Imagine if we were to say, oh no, we need to fix that. How can we change our education system to make sure we keep people down at the lower end there so we maintain the shape of this bell curve? Well, that's absolutely not what this is about. Just saying that the IQ is represented as a bell curve should not be something that we are trying to achieve. It's interesting to see how IQ is distributed, and the shape is interesting to look at and say, okay, well that makes sense. We've got people somewhat evenly distributed, and maybe seeing how it grows over time and in different environments. But if we start trying to create the shape, we're probably going to do really, really bad things for society. So what shape provides the most value for your application? Is it a square? Is it a triangle? Is it a pear or a strawberry? You know, the shapes don't really matter. If a banana-shaped test provided you with greater value, then you should have banana-shaped tests. Now, that's silly. I don't know how you would make banana-shaped tests, but the point is the shape may indicate how our tests are distributed, but the shape should just be interesting to look at. It probably shouldn't be driving what we're doing, especially if it makes us stop thinking about what's the value this is actually providing for us. Okay, curse number two. Believing that what was slow in 2006 is necessarily slow today. So here's a quote from Martin Fowler. The pyramid is based on the assumption that broad stack tests are expensive, slow, and brittle compared to more focused tests such as unit tests. And this is really, really good because if we forget that this is why we had pyramid tests, we might go ahead and keep building a testing pyramid even in cases where this is no longer true. And the reason I think this is so important is because if we do have tests that we can make faster, we can make them less brittle or less expensive, we might want a different shape. A testing pyramid might not be a good way to approach things if some of these statements are no longer true because we've got new tools or new techniques. So imagine a situation, if you had 1,000 UI tests that take 2 minutes each, and you're just going to run through all of them, you're looking at 33 hours. Well, that obviously takes a long time. That may not actually be worth it to you if it actually takes 33 hours before you get feedback. So that's way, way too slow in 2009, which is the time period I'm thinking of here. But what if those tests were really, really valuable? Well, what if we had a different way of doing things where we could actually make them run a lot faster? What if we had 4 servers and 20 containers on each server? Well, then the 1,000 UI tests that take 2 minutes each would only take 25 minutes to run. All of a sudden, we've changed what we used to avoid because it was slow. The slowness no longer has to be an issue. In fact, the hardware that you run this on, if it stands itself up and tears itself down in the cloud somewhere, may be even cheaper than what you were running your other tests on, where you actually had to have a box sitting under someone's desk or in a rack somewhere. So the point I'm trying to make here is that the cost and speed of running tests looks very different now than it did back in 2006, when maybe we were starting to think about the testing pyramid. And so we want to make sure that we're not using value propositions that were valid from 2006, but maybe aren't valid today. Curse number 3, ignoring improved ways of doing development. The pyramid was created as a response to UI tests being recorded by a team of testers. So you do development work, and then you take something that would record the screen, and then it would use that and it would play it back. There are tools to do this with Selenium now. Selenium, interestingly enough, was the cure for mercury poisoning, and there was, I think it grew into HP's testing tool, but there was a mercury, or a testing tool called Mercury, that would let you record stuff and do things like that. So Selenium was the antidote for mercury. That's where the name Selenium comes from, for the framework you can use to control your browser. But the pyramid was created as a response to UI tests being recorded by a team of testers. Behavior-driven development represents a fundamentally different way of doing development today. So behavior-driven development leverages test-driven development. So we've got 2 loops. We'll look at them different in a little bit, but you've got your behavior-driven development loop and then your test-driven development loop. It also represents requirements as executable specifications. It does the tests from the user's perspective, and the developers write the test back in code. And this is a very, very significant change, because devs writing back in code is a huge benefit of behavior-driven development, because a lot of the brittleness that you see when tests are being written after the fact are because the person who's actually dealing with the test and trying to update the test wasn't there when the changes were made to the application to understand how they work. So if you're in a situation where the developer is saying, hey, I need to change the application like this, 25 minutes later, I've got the feedback, oh, this test broke. Oh, that's right, I renamed this thing on the page. Let me change the name back or update my test to handle that name. Now I run my test. Okay, it works, and you move on. So you end up in a very different situation where you're getting the rapid feedback to not only develop your code, but develop your tests along with it and keep them in sync. There's also the page object pattern. And I'm not going to go into really deep detail, but whereas the recording the screen takes the screen and thinks of it, okay, here's what happens on the screen, and you may have thousands of these tests that expect the screen to look exactly like this. The page object pattern lets you abstract those things away and say, here is the API, or an abstracted generic way of how I'm going to interact with this screen. So I have a login page, and the login page is going to take a username and a password, and those fields are called username and password. Well, then if the and you may use that in 5,000 tests in different places. The page object pattern says, okay, but if someday that changes, and maybe now I need an email address and a password, or an email address and a 2-factor or something like that, I've now represented that all in just the way that page, the way I've defined the interface to that page. So I can change it in one place, and all my tests are automatically updated. So if you're dealing with pain, particularly in doing UI type testing, this can be used for other stuff as well, look up the page object pattern. Make sure your developers look up the page object pattern, because this is very, very powerful. Okay, a summary of the curses we talked about here are: don't try to create a pyramid. Now, keep in mind, I'm not saying that your test will not be shaped like a pyramid, but using that as trying to use that to drive how you create tests probably is not a good idea. You do want to enable the delivery of valuable software. Your tests might form a pyramid, or they might form some other shape, and that might be interesting to look at, but that shouldn't be determining what test you invest in. So what shape are the tests on your current project? Okay. Option A is what tests? You may not even have any tests. B is a pyramid. An ice cream cone, an inverted pyramid. A rectangle, we've got tests all the way through. An hourglass would be where you've got a bunch of UI tests, not many integration tests, and then a bunch of unit tests. Or banana, just because it's fun to say. I should have used a pineapple. I didn't think of that. There isn't a right answer here. This is just what are your tests doing. In different situations, you might be able to make a case for all of these being very valid, except for I don't know how you would actually do a banana, but maybe very valid for your particular situation. So I see a question as we're feeling this out. That's a good question, Taylor. When we get to a good spot, we'll do behavior-driven development. I think that type of thinking usually is rooted in a misunderstanding of what behavior-driven development does. because behavior-driven development is fundamentally a different way of doing development. If you see it as just a way of another way to add testing or just a way to do UI testing, you're not actually using behavior-driven development to drive a change in the way that you do development. And I've seen some people get some value from that, but it's not the same thing. It's just a different UI testing tool. And maybe that's good. Maybe that is valuable to you, and that's great if it is, but that's not changing your development process to try to get the full advantage of what behavior-driven development does. Behavior-driven development is very focused on creating the collaboration with the customer and getting that input right at the time that you're working on things and being able to iterate in small pieces all the way through. And the regression testing benefit of it is really great because you can make small changes and then get the full regression testing benefit of it. But that's just a piece of it. And oftentimes a very small piece of it that enables the rest of BDD rather than being the key thing that behavior-driven development is about. But that's a very good question. Okay, so we've got lots of distribution. A lot of us are in a pyramid, and that may be perfect, right? This might be exactly what your application needs to be doing, because it does make sense in a lot of situations that you would have fewer things in the UI. Maybe you can test more with a single UI test than with others, and you can catch other things in the unit level testing. On the other hand, there are some times, though, where the majority of the application, the unit tests, actually test a lot less than the UI test for you. We'll look at that, just getting ahead of myself here. Okay. If banana-shaped tests provide greater value, then you should have banana-shaped tests. The point should be the value you're getting from it. Behavior-driven development with test-driven development enables a new way of developing code. It may end up with more UI tests than a pyramid, because if you're trying to drive all of your application, all of your development based on how would the user experience this, you may end up with a lot more tests kind of at the top of the pyramid. Because you're trying to ask yourself, how do I prove this does what the user wants? Now, you can end up trying to use BDD and just skip the TDD part of it, and that's not a good situation to be in. The test-driven development is still very, very valuable for thinking about how you design the pieces of everything, improving that those work, and being able to make iterations on that. But you may end up with more investment in the UI tests if you're thinking of this from the standpoint of how does the user interact with this. Now, teams I've seen that have really done well with behavior-driven development often write a bunch of stuff that's testing the UI, and then they discover, you know what, we've tested this path all the way through, and now we need to test all the business rules of what you can do in this. So let's say there's 20 different combinations that you could select on this and go through this wizard. And oftentimes what they'll do is they'll say, okay, we probably don't want to, maybe we don't want to test all those different, 20 times 20, and now you've got like 400 different things that could happen. Maybe we actually want to test the path all the way through so we know we've hit all the UI code, and then we're going to create a really big table that tests all the different combinations that could happen, but we're going to hit the controller directly. Or we're going to represent it as behavior-driven development statements, but we're going to kind of say, okay, we've proved the UI, now we're going to hit just the business logic to show this works the way that you expect. So there's lots of things you can do like that. And in some ways, that kind of does push you from saying, okay, I've got a bunch of stuff in UI that maybe I'm saying I've gotten all the value from it, so now I'm going to push some of these down to integration or unit level, still proving out things from the customer's point of view. I'm going to make a statement here. I'm curious if you agree with it. So give me a thumbs up if you agree or a thumbs down if you disagree. So the way you test your software is the most important thing in determining how long that software will be able to evolve. So give me a thumbs up in the reactions if you think that's true. Thumbs down if you think it's not true. And it's fine. You can disagree with me. Okay, Ruth says no. Okay. Got most people are up. A few people saying down. Okay. So, and it would be very interesting, if we have time at the end, I'd like to hear the people that say that's not the case. My experience is, the reason that this has been my experience is because the longer something goes, if I can't prove it does what it's supposed to, I increasingly get to the point that any change I make has the potential to break something else. And so it's very, very difficult to continue to evolve something if every time you try to make a small change, especially if you're trying to make small changes to evolve things, if every time I try to make a small change, customer says, hey, this software has been great, we've been using it for 2 or 3 years, we want to tweak this one thing right here. Well, if I have really, really good testing in place and I can tweak that one thing, prove it works, and then give it to them, they're probably going to be fine with making that small investment to let it continue to evolve. If I can't prove that quickly, then they may ask for a small change that to them is like, okay, yeah, this should cost about $1,000 in time, and then we'll get it to our customer and start benefiting from it this week. But if they try to make a small change and we're like, okay, yeah, that's going to take 6 months for us to test just that small change, then there's a big hesitancy to make changes. And so you end up with more and more debt, if you will, or more and more things that need to be changed that haven't, just because it's hard to justify them. Then that happens from what the customer is asking for, but it also happens for the way that the developers think about the code. If I know that making a small change may break something and it's really expensive for me to prove it, if I find something that's wrong and could be improved, even something as simpler as saying, oh, we need to update this framework because it's out of date and there's some security concerns. If I can easily try the new framework, run all my tests, say, hey, that's good, let's push it out in the next change, I'm much more likely to do that and keep the software up to date, letting it continue to evolve, than if I know if I change something, it's going to take me 6 weeks of testing. So that's why I'm making that statement. Here's Martin Fowler, the one that we were quoting earlier, and he said, if my high-level tests are fast, reliable, and cheap to modify, then lower-level tests aren't needed. So he's actually saying, if I can run high-level tests and actually get a lot of value from them, and they give me good return on investment, then I don't need lower-level tests. Now, I am not telling you that you should go out and get rid of all your unit tests here. The point is, your higher level tests probably aren't always going to be fast, reliable, and cheap to modify. So you're going to have a balance there. But what I really like about this is Martin Fowler is calling out, he's thinking in terms of what's the value I get from this? How much does it cost me and how much value do I get from it? So you're thinking in terms of how much will it cost me to maintain this test, but also how much value do I get from it? And if those things are really, really expensive to maintain and very little value, maybe it doesn't make sense to go ahead and do them. But he's saying if they're really, really inexpensive to maintain, actually testing the high-level test from the standpoint of how the user experiences it is pretty high value being able to do that. And so you want to write tests that balance those things. So that's why I really like this quote, because it's not because it's telling you how your test should look for your particular situation. It's telling you what you need to value in trying to decide how you set up your tests. Okay, so I mentioned BDD and TDD. Here's what these loops look like. TDD, or behavior-driven development, we've done other talks on these, and I'll do more in the future, but write a scenario, watch it fail, make it executable. So now we have something that proves our application does not do what the customer expects it to do. Then we get into a loop here where we're going to write a simple test at a unit level, watch it fail, write code, the test eventually passes, we refactor, and we keep going through that loop in the TDD loop until our scenario passes, and then we move on to our next scenario. Those two things together are very, very powerful. And it often produce tests that look, this will often produce tests that look something like a bottom-heavy hourglass, because you've got lots of TDD tests being produced here, everything you need to drive your development. You may have fewer in the integration layers because, like Martin Fowler was saying, he may find the integration level layers don't provide any more value than the stuff that's at the higher level. And those things, and they're going to write those anyway, so there's fewer they're integrating, and that's all being tested when you test that it works from the standpoint of the user. So different things depending on your software, depending on your team's skill set, but these two things together will produce very good coverage and software that's usually pretty easy to evolve, or can be easy to evolve going forward.